Good day, everyone. Now we are in lesson 12, extreme values and optimization. One application of the derivatives is finding the maximum or minimum values of a function. A company owner may want to know the number of units of products to be produced to maximize the profit. An engineer might consider in his design of a tank what maximizes its capacity and what minimizes the scrap in the materials to be used for the constructions. The students may want to know what minimizes his weekly expenses. Such cases require optimization. Optimization is the process by which the values that would maximize or minimize another value are obtained. Okay, for the last example, number 3, determine the dimensions of the right circular cylinder at the greatest volume that can be inscribed in a right circular cone of radius 6 cm and height 9 cm. So ito ngayon yung ating figure. So yung ating cylinder ay naka-inscribe doon sa ating cone. Okay? Then kapag kinuha natin ang kanyang other prospectus, so ito ang kanyang magiging figure. Yung ating circular o yung circular cylinder ay inscribed dun sa ating cone at ang height ng ating cone ay 9 inches at yung radius naman ng ating cone ay 6 inches. Okay, let H and R respectively denote the height and radius of the cylinder. And the volume of the cylinder is pi r square times height. Looking at the central cross section of the cylinder and the cone, we can see similar triangles. Dito sa ating second figure, makikita natin yung similar triangle. So, ang makikita natin doon na similar triangle ay ang gagamitin natin yung definition ng similar triangles or similarity of triangles. So we have the ratio or the proportion of 6 over 6 minus r equals to 9 over h. Since ang ating height ay 9 cm at ang ating radius naman ay 6 cm, so gamitin natin yung ating figure na cone. Then dun sa cone, naka-inscribe naman yung ating cylinder. Then mapapansin mo dun sa cone natin ay meron tayo dong right triangle. Itong yellow. Kinulayan natin ng yellow, no? Then dun sa right triangle, merong tayong dalawang triangle na makikita, itong red triangle at yung isa naman ay yung violet triangle. Then pag kinuha natin yung dimension ng dalawang triangle, itong side ng red triangle ay 9 minus h kasi yung buong height ng ating cone ay 9 cm. So kaya pag itong portion lang ng red triangle, 9 minus h. Then yung nasa base naman niya ay yun yung ating radius r. Next, din naman tayo sa violet triangle. Then meron tayong height. At yung height na yon, yun din ang magiging height ng ating cylinder. Then yung ating base naman ng violet triangle, since ang buong base ng ating cone ay 6 cm, kaya ang mangyayari ngayon ay 6 minus r para naman dun sa base ng violet triangle. Then, sa part na to, since ang target natin ay itong side ng which is connected inside ng violet at ng red, pwede tayong gumamit ng definition ng slope. Diba? Ang slope ay rise over run. So, ang rise natin ay ang 9 cm at yung ating run naman ay 6 cm. So, in lowest term, 9 divided 6 ay 3 halves. Then, pwede natin kuhanin ang proportion nitong height at saka ng ating itong violet triangle using the definition ng ating slope. So, we have the height over 6 minus r dun sa ating violet equals sa slope naman ng big triangle, which is 3 halves. Then, equate natin for h. So, solve natin in terms of h. So, meron tayong cross product ng 3 times 6 minus r over 2. Then, pwede natin siyang i-evaluate. Distribute natin yung 3 times 6, magiging 18. 18 divides 2 is 9. Then, 3 times negative r, we have negative 3 r over 2. Okay? Then, save natin ito. Gagamitin natin ito mamaya. Next in line, the volume of the cylinder. Balikan natin yung volume ng cylinder. And that is V equals pi r squared times height. So, instead of h, ito ngayon yung ating gagamitin. Substitute lang natin. Okay, so we have equals pi r squared times the quantity of 9 minus 3 halves r. Then, evaluate natin, distribute natin yung pi r squared into 9. So, meron tayong 9 pi r squared. Then, pi r squared distribute sa negative 3 halves r. Meron tayong negative 3 halves pi r cubed. Okay, so save natin itong part na to. We can now write our objective functions as the v of r equals 9 pi r squared minus 3 halves pi r cubed. Okay, ito ngayon yung ating objective functions. Pwede rin natin simplify itong v of r natin. Common factor nila ay 3 pi r squared. So, 9 pi r squared divided by 3 pi r squared. Meron na tayong 3 inside the quantity. Then, 3 pi r squared divided by negative 3 halves pi r cubed. Matitira na lang yung cancel na yung 3. So, matitira na lang yung r over 2. Okay? Then, kukuhanin naman natin. And it is to be maximized. And it is to be maximized. Clearly, the radius r is an element of closed interval 0, 6. Since v is continuous on the closed interval 0, 6. So the extreme value theorem is applicable. Now we are going to find the derivative of the v of r. So we have the v prime of r. Okay, ito ang pagkuha natin ng derivative. So mangyayari dito ay 2 times 9, 18 pi r. Okay, so meron tayong 18 pi r. Then, so sunod naman ay 3 times 3, 9 over 2 pi r square. Okay, so meron tayong negative 9 over 2 pi r square. Then, equate natin siya to 0 para makuha yung critical number. Pag in-equate natin sa 0, pwedeng makuha natin yung common factor which is 9 pi r. 18 pi r divided by 9 pi r, meron 2. Then negative 9 halves pi r squared divided by 9 pi r, cancel na isang r. At yung pi cancel. Pati yung 9, matitira na lang yung r over 2. So dito sa part na to ay magiging 0 na to. So ito 2 minus r over 2 equate to 0. And then meron tayong r equals 4. So yung r natin, pag nilagay natin into table, critical number kasama yung ating close interval. Then meron tayong ngayong and hence our only critical number is 4 on the interval 0, 6. We now compare the functional values at the endpoints and the critical points. So we have the table for R, ang ating domain 0 for 6 at ang kailangan natin ay B of R. So solve natin individually. Let's start with B R0. So B of 0. So 3 times 0 squared, quantity 3 minus 0 over 2. And the result is 0. So magiging 0 ngayon yung ating first column. The next for R4. Or dito muna sa isa pang yung sa close interval 6. So ito ay 6 ito B of 6. So yung ating x, so 6 square. Then 3 minus 6 over 2. 6 over 2 ay 3. So kaya 3 minus 3 is 0. So pag tinimes natin yan with any factor, still 0. Kaya itong part na to ay 0 pa rin. Yan. Then yung last yung 4. So B of 4 equals 3 pi 4 square. Then 3 minus 4 over 2. So ito ay 3 minus 4 over 2 ay 1. At ito ay magiging 16. So 3 pi 16 times 16 times 1. And we have 48 pi. Kaya itong part na to ay 48 pi. So, we see that the volume is maximized when R is 4 with value V of 4 equals 48 pi. To find the dimension, we solve for H. If R is 4, so balikan natin yung kaninang similar triangle natin, yung 6 over 6 minus 4. Kasi ang R natin, ito ay R. So, ang R value ng R ay 4 equals 9 over H. Then, solve for H. Gamitan lang natin ng cross product. So, meron tayo ngayong ito, yung 6 minus 4, 2 na lang yan. So, cross product natin. H equals 9 times 2 over 6. At meron tayong 3. Therefore, the largest circular cylinder that can be inscribed in given cone has dimensions of radius R equals 4 centimeter and height H equals 3 centimeter. And that's it.